Welcome everyone to a math tutorial video learning about synthetic division and division of polynomials. So this is the last video in a series of polynomial operations. We've done adding, we've done subtracting, we've done multiplying, and we've been looking at some division. And this synthetic division, it uses the ideas and the principles of long division, but it uses more shortcuts. So we ignore a lot of the variables and we're able to focus on just coefficients. And once you get the hang of it and understand how the pattern works, how the sequence of what to put everything in, how it all works, it actually is much easier and quicker to do division with polynomials. All right, but there's a couple things we need to preface first. So the first is it only works, we can only do synthetic division if the divisor is a binomial. So here we're dividing by x plus 4, so that's good. The leading coefficient is 1. So we have a 1x right there. And if we have those two things in place, then we're able to do synthetic division. But if I had, like, for example, a 3x plus 4, or if I had a 3x squared plus 4, those wouldn't work. So I guess the division, that's what I should add, is it has to be a first degree binomial. When we say that, just means x has to be to the first power. Okay, but this example problem will work. So we got 2x to the fourth plus 3x to the third minus 17x squared plus 11x minus 4. And I'm going to divide all that by this binomial x plus 4. And since it meets these criteria, we can go ahead and do synthetic division. If it didn't, then I would have to actually go back and try and use long division instead to do the problem. All right, so here's how we set this up. I'm going to draw a little box up here, and then we need a line over here. We're just kind of setting it up as we go. This box up here is for the divisor, and if I have x plus 4, I do the opposite of plus 4. I'm going to check and see. I'm going to be working with a minus 4. It comes down to the minus 4 because negative 4 plus 4 is 0, and if it's a divisor, we're looking to see what zeros happen. But anyways, we put the opposite sign. This is what I'm going to work with in my synthetic division. Along the top, along here, I'm going to put the coefficients. So I'm going to put 2, 3, negative 17, 11, and negative 4. So we've got 2, 3, negative 17, 11, and negative 4. All right, here we go. Let's start this process. The first thing we do is we drop down the 2 right here. Now I take my negative 4, we multiply the 2. Negative 4 times 2 is going to give me negative 8, and we put the negative 8 right here. Now we add together. 3 plus negative 8 is going to be negative 5. And now we multiply again. Negative 4 times negative 5 is going to give me a positive 20. I go down and I add. Negative 17 plus 20 is going to give me 3. And now I multiply by negative 4. Negative 4 times 3 is going to give me negative 12. Go down. 11 plus negative 12 is going to be negative 1. And we do one final multiplication. Negative 4 times negative 1 gives me positive 4. And then we add our final two columns down. The final column down, negative 4 plus 4 gives me 0. Okay, what did we just do? So hopefully you followed the number pattern of where we drop down the first one and then it's multiplying by -4 over and over again to get each of the following values. Here, let me color code it the same way. So we multiplied 2 by -4 to get -8. We multiplied -5 by -4 to get 20. 3 times -4 gave me the -12, and -1 times -4 gave me the 4. But every time we would do that over here, we always added down the two columns. We always added down the column to get each of these values. Drop down the 2, but then 3 plus -8 was -5, -17 plus 20 was 3, 11 plus -12 was -1, and -4 plus 4 was 0. So it's this pattern of adding together, then multiplying, adding together, then multiplying, adding together, then multiplying. And once you get the hang of that, it's pretty easy to do. Notice I didn't have to do much writing with any variables. There's no x's involved, no complicated moving things around in terms. It's kind of this process over and over again. But what have we found? What did we actually do? Well, this end down here is the remainder. And in this case, we can see that the remainder was 0. So when I divide these polynomials, this x plus 4 divides evenly into this 5-term polynomial. That's kind of nice. We can tell that from my synthetic division. These other terms are a polynomial in descending order. The last term is the constant term, so that's my -1. This is my x term, so it's 3x. This is my x squared, so minus 5x squared. The 3 was positive, and this is my cubed term, so 2x to the third. And there is our quotient. So 2x to the fourth plus 3x cubed minus 17x squared plus 11x minus 4. If I divide that by x plus 4, I get a 4-term polynomial, and this is what it equals. This is my quotient right here. And we used synthetic division to set it up and actually figure all that out. So some people really like synthetic division a lot nicer than long division with polynomials. But again, we have to preface that it only works in certain cases. If we're dividing by a binomial, if the leading coefficient is 1, and if it's a first-degree binomial. So it only works for special cases of division. All right, hopefully that's helpful for you in just seeing the synthetic division worked out and being able to practice doing some of this on your own.